Guys, some of you asked me how to make a graph for the lab, so I'm going to share with you real quick how to make a graph for the enzyme activity lab. And this also applies to the previous lab where you measured the cell surface area and volume, calculate the ratio, and then make a graph using the ratio and time for the molecules to travel to the center of the cell. I wanted to correct myself real quick before I start. Yesterday, I said you need to make a bar graph for the enzyme activity lab, and that's not true. And this is why yesterday I was looking at the file from eScience. I was looking at this table. I didn't check the real table, so I thought that you only collect data for three treatments, right? The room temperature, hot and cold, and you just collect however centimeters you have measured. Okay, so this is not a continuous experiment, right? The independent variable is not continuous. Instead, it has three distinct treatments: room temperature, hot, and cold. So if you have to graph the data from this table, you are definitely going to use a bar graph, or some of you call it a column graph. But yesterday, I got an email from a student, from Kathleen. Shout out to Kathleen. She said, "Dr. Yu, I don't think I can make a bar graph to express all the data I collected for the enzyme activity." So that prompted me to double check the data that you're required to collect. And then I look at data, and then I noticed, oh, so you do need to collect data for different time periods. Now, the time is continuous, right? So you measure something at 0, 30, 60, 90. But this is a continuous series. It's not a distinct groups. So in this case, you do need to make a line graph and not a bar graph. Okay, now I'm going to show you how to do it real quick. This is an Excel spreadsheet, and I just make some data up. I didn't really go collect the data. So your graph may look very different than mine. And again, because my data, they're fake. They're not the real data. All right, and then you can arrange the column like this. I'm going to make it a little bigger. So the first column is time, and then the other three columns are the data you collected for the three treatments, three different temperatures. All right, now we are going to graph the data using the time as the x-axis. So that's the independent variable, right? Depending on what time you are looking at, you are going to collect different amount of oxygen. And then we're going to have three different lines to represent the three different conditions, right? Three different temperatures. All right, now Excel has made this really, really easy. So all you need to do is to highlight all the data, okay, highlight it, and then go to Insert. Okay, now yesterday I went specifically to line chart. Now you're going to have to make some adjustments, but the easiest way is actually to go to the recommended chart. So if you click on here, and the third one is the line chart. And you can see everything looks right? The time is on the x-axis, and the amount of oxygen is on the y-axis. And you have three different lines to represent the different times. Or sorry, not different times, different temperatures. So you just click OK. All right, now that's your chart. Yesterday I said we do need to label the two axes, right? So that when people look at the chart, they know what x-axis represents for and what y-axis represents. So what you can do is, this is kind of in the way, right? So you can move this to the top so that it's easier to see. Okay? All right, now like I said, you can add a chart title for our kind of lab workbook. You can say, let's be accurate, so you can actually copy and paste this. So you can effect of temperature on enzyme activity. Copy and paste. So Control V, there we go. And if you want to be very specific, what's this? You can add, so this is oxygen production. And you can make this a little bit smaller to fit the box. So go to Home, and you can change the size of the text. So let's click on over here, a little bit smaller. There we go. And then you do need to add a title for both axes. Right, so let's go back to Chart Tools over here and go to Design and add Chart Element on the upper left corner. So again, axis titles. All right, now let's add the horizontal title. That's going to be time. Time. And you do need to add the unit to the axis if there is any. Now we're going to add the title for the y-axis, and that's going to be oxygen production, right? And again, you need to add a unit, right? So what's the unit? Let's go back to the table. So that's centimeter cube. There we go. All right. Now the chart is done. So you can see that as time goes on, the oxygen production increases, right? That makes sense. The more time you give the enzyme and the substrate to work, then you're going to have a more oxygen generated. And then another thing you can see is that the oxygen production is going to be the highest at the medium temperature, 25 degrees Celsius, right? So the orange line you can see is above the gray and the blue line. So this shows you that 25 degrees Celsius is going to be the ideal or the optimal temperature for this particular enzyme. Now, I don't know what your result is going to look like. Your data might be different than mine, right? Again, my data are made up. They're not real data. So I'm looking forward to seeing what you guys get for this particular experiment. All right, let me know if you have any questions.